Charles Darwin visited the Galapagos Islands in the 1830s. Darwin became obsessed with the finches on each island because they were all pretty similar to the finches on the other islands, and also very similar to the ones he found on the mainland of South America. But they were also obviously their own species because they had a variety of physical changes. Darwin believed that the process that led to these finches becoming separate species was due to natural selection, which causes populations to become adapted to their environments over time. And in this video, I'm going to show you 5 different examples that will prove how a single species can fully develop into a variety of species due to the environment they live in, the food resources available to them, etc. And the first piece of evidence to prove this are the Galapagos tortoises. The Galapagos tortoises have 2 very different shapes, each adapted for different feeding habits needed on low arid islands versus high lusher islands. Although there is a great amount of variation in size and shape among Galapagos tortoises, 2 main forms exist: the domed carapace and the saddleback carapace. Domed tortoises tend to be much larger in size. They live on islands where there is an abundance of vegetation close to the ground, making it less necessary for the animals to raise their heads to feed. Now, saddleback shells evolved on the arid islands in response to the lack of available food during drought. This adaptation makes it easier for them to lift their heads high to eat tree cactus and to resolve disputes over limited food resources, which they do through raising their head as high as possible during social interactions. Now, my second piece of evidence are the Galapagos finches. This little warbler finch with its very fine needle-like beak is perfect for picking off insects. This one is a woodpecker finch with a rather more robust beak. It concentrates on beetle larvae and termite larvae. Then we have the cactus finch with a much longer, sharp, pointed beak, which proves into cactus flowers. And then these 3 species are the large, medium, and small ground finches. So basically, the beaks are tools, and you need the right tool for the right job. My third piece of evidence are camels. There are 2 types, the dromedary camels and the Bactrian camels. The dromedary camels have 1 hump and can be found in Africa in very harsh, warm temperatures, while the Bactrian camels have 2 humps. They can be found mainly in Asia and can withstand 40 degrees below zero and a warm temperature up to 40 degrees Celsius. Dromedary camels have long necks and limbs to help the camels run faster, which is very important because the origin of camels from the Great Plains had few trees or bushes for animals to hide in, so they needed speed to outrun predators. On the other hand, Bactrian camels had small limbs because they mainly live in high rocky mountains, and that allows them to have a better grip and control of their body. Lastly, dromedary camels have shorter and thinner hair to avoid death during harsh warm weather, whilst Bactrian camels have longer and thicker fur to prevail in cold weather. My fourth piece of evidence is the rock pocket mice. They live in the deserts of the American Southwest. Ancestral pocket mice had light-colored coats that blended in with the region's rocks and sandy soil, keeping the mice hidden from the owl predators. Starting about 1.7 million years ago, a series of volcanic eruptions spewed out wide trails of black lava that wove right through the middle of pocket mouse territory. Today, there are 2 forms of pocket mice: light-colored mice that live on sandy soil and dark-colored mice that live on black lava rock. The dark mice came about through the process of evolution. Naturally occurring mutations to coat color genes produce mice with dark fur. On black roads, dark mice had an advantage over light mice. They were better hidden from predators. They survived and reproduced, passing their dark fur genes to their offspring, which still survive today. My final piece of evidence are penguins. There exists a variety of different species, but for today's purpose, we'll stick to 2 of them: the jackass, or better known Blackfoot penguin, and the emperor penguin. The jackass penguin is confined to the southwestern coast of Africa. They stay cool by spending most of their day at sea, returning to the mainland at night. But also, they have another adaptation to help keep cool during warmer weather. They have a special pink gland above their eyes. When temperatures soar, blood is sent to these glands to be cooled by surrounding air. Now, emperor penguins live in the Antarctic, in some of the most desolate, coldest, and windiest places in the world. Actually, some emperor penguins are the only birds that never set foot on land. Emperor penguins, when it gets very cold, can puff their feathers out to trap more air for even better insulation. Now, to keep dry and insulated in cold water, the jackass penguins are covered in dense, waterproof feathers. These feathers are white on the belly and black on the back, which aids in camouflage. Their white belly will blend with the light when predators look up at them from below the water, and their black backs meld with the darker seas when predators look down on them from above in the sky.